So here we have an example of an ASCII encoder 2 and a 7-segment decoder example. Now so as you can see here, we do have a different inputs, or this is what we call the ASCII, which is the keyboard that represents a particular number, say for example, and we will be encoding this into its equivalent binary data. So when you say encoder, so from any signal to binary data. So in this case, we do have so we have 40, 35, 28, and 15, which can be represented by A, B, C, and D. Okay, so, and of course, we have our output X and Y. Okay, so in this case, we will be representing 15 as 0, 0, 28, so 15 is 0, 0. Okay, the rest will be 0. 0, 1 will be the 28, so the rest will not be chosen. 1, 0 will be 35, okay, and 1, 1 is 40. Okay, so as you can see, so from here we can be able to derive our equation for x, okay, for the value of x. So how do we do that? So we will get the combinations of this circuit. Okay, so with that, we do have for x, okay, we have a solution that is bar, a bar, b, c bar, d bar, or, okay, this is sum of product. So we have also a, b bar, c bar, and d bar. So as you can see from our given our equation, given our circuit, we do have a bar. So we have a bar, b, c bar, and d bar, and of course we have a, b bar, c bar, and d bar, okay, for our output of x. Okay, so for our output of y, which is given by this, okay, so where do we see that? So we have this output and the same thing with the first one. So with that, we have a solution that is y, and what will be our equations? Our equation will be a bar, b bar, c, d bar, or with a, b bar, c bar, or d bar. So as you can see, we have here a bar, b bar, c, and d bar, and for the next term we have a, b bar, c bar, or d bar. So actually you can just have put the output from here and goes in there. Okay, so that's our solution. That's another solution. Now, so this is the encoder part. So that's why we can have, that's where we can derive or get the value of our xy. So as you can see, we've already encoded the 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 value from this button, okay, which is actually a temperature, and we encoded this value a into its equivalent binary. Now, so what happens here? Okay, so we have here input x and y, okay, and we do have two 7 segment, and this 2 7 segment is let me get another color. Okay, so in this 2 7 segment is represented by our say A1, B1, C1, and D1, which is this part. So A, B, C, and D, and of course for the second data we have, so A2, B2, C2, and D2. So A2, B2, C2, and D2. So for whenever we have a binary value 0, 0, 0, 1, 1, 0, and 1, 1, okay, what it will do is it will be deducted from a value of 30. So meaning 30, so 30 minus 15 is equal to 15. So what happens is you have to decode. So this one is for the first 7 segment, or the most significant bit, or the most significant 7 segment, and this will be the least significant 7 segment. So that means we have 1. So how do we represent it? Represent 1 how in what we call this, binary, okay, or in the 7 segment. Okay, so we have there 0, 0, 0, 1, and 5 is 0, 1, 0, 0, 0, 1, 0, 1. Okay, 5. Then the next one we have 28. So 30 minus 28 is 0, 2, or 2. So that means we have 0, 0, 0, 0, and 0, 0, 1, 0. Okay. And then also for the third one we have 30. So 35 minus 30 is 5. So 0, 0, 0, 0, 0, 1, 0, 1. And lastly, we have 40 minus 30 is 10. So we have there 0, 0, 0, 1 for 1, and that will be 0, 0, 0, 0. So here we have already decoded, so we can be able to decode this given binary data or information. So to solve that, okay, or to get the, okay, so to get the circuit or the equation for this, we all know that A1 is equal to B1 is equal to C1, which is equal to 0. So this is the one. You have there the 0. But for D1, okay, so let's write the K-map for this. For the D1, what is our equation? So for the D1, we have um, sum of product, or SOP, which is comprised of X bar, Y bar, ORed with X and Y. Okay. And for A2, so A2 also is equal to 0. So we have here equal to A2 still equal to 0. So let's just edit this one. So as you can see, our A2, which is this one, is connected to the ground or 0. How about B2? So B2, can we have a K-map of this? So let's try out the K-map for B2. So 0x and y, 0 and 1, 0 and 1. So B2 is 0, 0. That will be 1. 0, 1 is 0. 1, 0 is 1. And 1, 1 is 0. So we have here this given equation, which is B2 is equal to what value? B2 is equal to y bar. Okay, so that's why, as you can see, so let's check this given equation. So as you can see, based from this, okay, this is the one. So you have their X bar and Y bar, ORed with X and Y. Okay, how about the B2 Y bar? So our B2, okay, our B2 is connected to our Y bar. Okay. How about C2? So C2 is, only have this equation, which is x bar y. So as you can see, our C2 is x bar y. And lastly, of course, we have D2, which is actually equal to B2. So D2 is equal to B2, which means we have Y bar. So as you can see, we have here Y bar. So Y bar. Okay. So here we have an equation that includes an encoder, and and a given binary information is again decoded into difference of temperature, okay, using the 7 segment display.